In this lesson, we are going to start to talk about acid and base titrations. Before you proceed with this video, ensure that you have watched the video that I have posted about the proper titration techniques. By watching this video, it will make the theory in this lesson a little bit more understandable. A titration is the progressive addition of one reactant to another until stoichiometrically equivalent moles of each substance has been added. Please note that this is stoichiometrically equivalent moles of each substance has been added, not volume, concentration, or mass. It is the addition of one solution of known concentration, and if we know the concentration, that is the titrant, to a solution of unknown concentration, which is called the sample. Titrations are used to determine the unknown concentration, meaning we have a known concentration of a base or acid, and to that we add to an unknown concentration of the other. When neutralization has occurred, we can then calculate the unknown concentration, which we will be doing later in this lesson. The equivalence point is the point where you have equivalent number of moles of an acid and base. So again, you have equivalent number of moles. It's determined using an indicator, and an indicator is a substance that changes color when there is an equivalent number of moles, and it indicates that neutralization has occurred. The end point, on the other hand, is the point in the titration where the indicator actually changes color. You can think of equivalence point as the theoretical point. It's the point in which you calculated something should happen. End point is more like the actual point or actual yield from back in chemistry 2202. And that's when you're actually doing the experiment in the lab, and it's the point where the indicator changes color to your own eye. Ideally, we want that to be the same as the equivalence point, but due to errors in the lab, that's rarely the case. You should also know the definition of a primary standard. A primary standard is a solution that can be prepared from a pure form of the solute to a precise molar concentration. This is a pictorial representation of a titration apparatus. This should look familiar to you if you've watched the video on proper titration techniques. You should be aware of the types of equipment that is used in a titration. We have a burette, and the burette is used for the known concentration. This is normally of the base, but know that it can be of the acid. We then turn a stopcock in order to release the known concentration into the Erlenmeyer flask, which will have the unknown concentration present. This could be a base, this could be an acid. Inside of the Erlenmeyer flask, we will have an indicator. That will change color when neutralization has occurred. Recall from Science 1206 that an acid and base reacting together will always create a salt plus water. There are several examples listed. Please remind yourself of this or review your Science 1206 notes. There are 4 different types of acid and base titrations. We can have a strong acid and a strong base, a weak acid and a strong base, a strong acid and a weak base, and a weak acid and a weak base. You are responsible for being aware of the pH at the equivalence point in each of these types of titrations. For example, if we have a strong acid, which is normally in a pH of 0 to 2, with a strong base, which is normally in the pH range of 12 to 14, at equivalence point, when there's an equal amount of each of these, then that will have a pH at equivalence point of about 7, or neutral. This should make sense. We have equal amounts of a strong acid and a strong base that's undergoing a neutralization reaction to create a salt and water, and salty water would be neutral. Then we have a weak acid and a strong base. A weak acid would have a pH range anywhere of 2 to 7, whereas a strong base would have a pH of about 12 to 14. It should make sense that the strong base would have a greater effect on this reaction than a weak acid. Therefore, the pH at the equivalence point will be greater than 7. Think of taking the average of a number between 12 and 14 and a number between 2 and 7. That average will be greater than 7. When we have a strong acid and a weak base, a strong acid has a pH of about 0 to 2. A weak base will have a pH anywhere above 7 to about 12. If you were to take the average of these two numbers, the pH at equivalence point would be less than 7. Again, the strong acid has a greater pull on the reaction than a weak base. Then we have a weak acid and a weak base. Since a weak acid can be anywhere between 2 and 7, and a weak base can be anywhere between 7 and 12, it's really unsure of what the pH at the equivalence point would be. It all depends on where in the range the weak acid is and where in the range the weak base is. So we cannot accurately determine what the pH at the equivalence point would be. We can't say that it will always be greater than or less than 7, so we just say that it's unknown. We can use the results of an acid-base titration to predict the concentration of an unknown in the titration, or to find the volume of acid or base needed for the titration. I will go through the steps involved in this now. However, you will notice that this type of question is identical to those seen in Chemistry 2202, and no new material is presented here. To solve these types of problems, you must first write a balanced chemical equation, whether that's a double replacement reaction or a non-ionic reaction, and identify and record the required and given substances. Once you've recorded the required and given substances, you can take the species in which you know everything about to convert to moles, using either mass over molar mass or concentration times volume. Once you have the number of moles of one of the species, you can find the number of moles of the other species that you're looking for in the problem by using the mole ratio, where number of moles required is equal to number of moles given times the coefficient of the required over the coefficient of the given. Once you have calculated the number of moles of the required, you can then answer the question, whether it's asking for how much mass is needed, the volume that's required, or the concentration. Let's put this to the test by going through example number 1. Determine the concentration of sodium hydroxide if 25 milliliters of sodium hydroxide is neutralized by 50 milliliters of 2 molar hydrochloric acid. Step 1 is to write out the balanced chemical equation. Between NaOH and HCl. Remember that this is a neutralization reaction from Science 1206. This will give us salt and water. At this point, it is also balanced. You should also write the information given and required under the appropriate species. We are told that we have 25 milliliters of sodium hydroxide. We have 50 milliliters of hydrochloric acid, and the concentration is 2 molar. At this point, you should see that we have the concentration and the volume of hydrochloric acid. So from there, we can get the number of moles of hydrochloric acid using C times V. The concentration is 2 molar, and the volume, remember that molar means moles per liter, so you'll have to put the milliliters into liters. So we will have 0.050 liters. Keeping the appropriate number of significant figures, this would be 0.10 moles of HCl. To find the number of moles of sodium hydroxide, we have to use the mole ratio, where we have the number of moles given times the coefficient of the required. We are required to find the concentration of sodium hydroxide. That has a coefficient of 1. We were given all of the information about HCl. That also has a coefficient of 1. So we have the same number of moles of sodium hydroxide. Lastly, to find the concentration of sodium hydroxide, we will use moles divided by volume. We have 0.1 moles of sodium hydroxide in a given volume of 0.025 liters. To the appropriate number of significant figures, the concentration of sodium hydroxide is 4 moles per liter. Example 2. Calculate the volume of 0.5 molar sulfuric acid required to completely neutralize 40 milliliters of 0.9 molar lithium hydroxide. Step number 1 would be to write out the reaction between sulfuric acid and lithium hydroxide. Unlike the last example, when you write this out, it is not yet balanced. Once it is balanced, write down what you need and what you have. It says calculate the volume of 0.5 molar sulfuric acid required to completely neutralize 40 milliliters of 0.90 molar lithium hydroxide. Once you've written out what you have and what you're required to find, you should see that we have enough information to find the number of moles of lithium hydroxide using C times V. We have 0.90 molar times 0.040 liters. Always remember in this case to convert your milliliters to liters since we're multiplying it by moles per liter. This will give us 0.036 moles of lithium hydroxide. We can then find the number of moles of sulfuric acid using our mole ratio. We have the number of moles given times the coefficient required. We're required to find the volume of sulfuric acid. That has a coefficient of 1. And we were given enough information about lithium hydroxide, and that has a coefficient of 2, to give us 0.018 moles of sulfuric acid. Lastly, we can find the volume of sulfuric acid using number of moles divided by the concentration. You can look back at this formula and rearrange for volume is equal to. We have 0.018 moles divided by a concentration given as 0.50 molar. This will give us a volume of 0.036 liters or 36 milliliters. At this point, you can now go ahead and work on the exercises.